Take down the next numerical. A 250 kVA, 50 Hz, 3-phase core type transformer has the following data. Length of core plus twice height of yoke is equal to 85 centimeter. Center to center distance between core is 32 centimeter. Outside diameter of HV winding is equal to 31 centimeter. Total iron loss 1.5 kilowatt. It's a kilowatt. Please take it as a kilowatt. Copper loss in LV winding is equal to 1.2 kilowatt. And copper loss in HV winding is 3.4 kilowatt. Calculate dimension of tank, temperature rise, number of cooling tubes and its arrangement if maximum permissible temperature rise is 45 degrees Celsius. Clearance along length is equal to 8 centimeter, along breadth 10 centimeter, and along base and top is 35 centimeter. First, write down the given things. kVA is 250. Height of transformer is given as 85 centimeter and capital D 32 centimeter. Delta H 35 centimeter. Delta B 10 centimeter. Delta W 8 centimeter. And the next, he has given the total loss in terms of iron and copper loss. As we know that it is given that the iron loss is 1.2 kilowatt, copper loss is 3.4 in LV winding and 1.5 in HV winding respectively. So when you add, you'll get the complete losses, that is W is equal to 6.1 kilowatt. The outside diameter of HV winding is given as DOHV is equal to 31 centimeter. And already we have seen in design the breadth of transformer is equal to DOHV is equal to 31 centimeter. The width of transformer is not directly given, but we can calculate it. We know that WTR is equal to 2D plus DOHV. Here I am taking 2D plus DOHV because it's a 3-phase transformer. If it's a single phase transformer, then it will be D plus DOHV. So width of transformer is 95 centimeter or 0.95 meter. As usual, first you have to calculate the tank dimension. So first let us calculate HT is equal to HTR plus delta H. Already here delta H value is given as 35. If it's not given, you have to take the value from the range, that is 30 to 60 centimeter. So the HT is 1.2 meters. Similarly, BT is equal to 0.41 meter and WT is equal to 1.03 meter. The next step in this kind of numericals is to find out the temperature rise theta R, and this can be calculated as W is equal to 12.5 St theta R. In this we know W value, we don't know St, we don't know theta R. First let us calculate St. We know that St is equal to 2 into HT into the bracket WT plus BT. Substitute the values. The surface area of tank St is equal to 3.456 meter square. So from the above equation, that is W equal to 12.5 St theta R, you can directly calculate theta R as 141 degrees Celsius. So in the numerical it is asked to find out the total number of cooling tubes to restrict the temperature rise to 45 degrees Celsius. Therefore, the total loss is equal to 12.5 St theta plus 8.8 AT theta. From this we can find out the total area of cooling tubes. AT is equal to 6100 minus 12.5 into 3.456 into 45 whole divided by 8.8 into 45. Here you might be getting confused why I have written 8.8 80 theta, because it's given the convention is improved by 35%. Therefore 80 is equal to 10.49 meter square. After calculating the total area of cooling tube, you have to calculate the area of one cooling tube, that is 81 is equal to pi dt into LT. As I have told you, dt and LT value if not given, by default take dt as 5 cm and LT as 90% of total height of transformer tank. Therefore 81 is equal to 0.1696 meter square. The number of cooling tubes can be calculated as n is equal to 80 by 81. Substitute the value and the number of cooling tubes required are 62. Let us understand the schematic and arrangement of cooling tubes. So before that, first you have to find out the total number of cooling tubes along the width and along the breadth. The spacing between cooling tubes will be standard 7.5 cm unless it is mentioned in the numerical. Therefore, the number of cooling tubes along the width is given as width of transformer tank divided by 7.5. So which is nothing but 13.7. After rounding, it will be 14. Number of cooling tubes along the breadth will be equal to breadth of transformer tank divided by 7.5, which is nothing but 5.4. So you can take it as 5. So to draw the schematic arrangement, first you have to draw the plan of transformer tank as shown in figure. We know that along the length we are going to place 14 cooling tubes and along the breadth 5. So let's start. Let's start with the number 1. Along the width from 1 to 14 we are going to place. Along the breadth we are going to place 5, that is number from 15 to 19. Then along again length 20 to 33, and then next along the breadth 34 to 38. The total number of cooling tubes required are 62, but so far we have used only 38. It means that we have to go for second row arrangement also. So let us see how to do that one. The total number of cooling tubes to be placed are 62. Now arranged are 38, remaining are 24. Remember, 24 is lesser than 38, so therefore you have to divide it into two equal parts, that is 12 and 12. Again 12 I am going to divide into two parts, that is 7 and 5. So you might be confused why I have taken here 7 and 5. As I have already told you, the number of cooling tubes along the width are 14. So when you divide 14 by 2, the 7 will be the number. And along the breadth we can place 5. The maximum number is 5. So I am taking 7 and 5. So it means 7 I am going to place cooling tubes along the width in second row arrangement and 5 along the breadth in second row arrangement. Let us continue. So we have stopped at number 38. Let's continue. The 39th cooling tube is again placed along the width, and how many you are going to place now? 7. So add 7 numbers. The last number is 45. Along the breadth we are going to place 5, that is from 46 to 50. Again along length 51 to 57. Again along breadth 58 to 62. So the total number of cooling tubes required are 62. We have placed all the cooling tubes. This is how your numerical completes. Thank you.